The surface of moon is very dusty. And the dust on the moon is completely different from what we have on Earth. First of all, there's no atmosphere on the moon, and there's a lot of irradiation on the moon. So the dust on the moon, they are very sharp, and they are very sticky, and actually they are very toxic. So how to mitigate this kind of dust problem, we need to understand how would the interaction of the lunar dust with the surface. This project actually focuses on, I would say, simulated lunar surface. So we will have a very high vacuum. We are not going to have any moisture there. We will introduce the irradiation there. Therefore, we can use a specific instrument we call the atomic force microscope to study the specific interaction of the lunar dust simulate on the surface. My role is to provide the surface. We are going to have the surface with a different surface structure, hardness, conductivity, and I'm going to give this surface to Dr. Tarek, who is going to do the AFM studies, and also Dr. Dove, and she has a vacuum chamber and irradiation source, so we're gonna use that vacuum chamber to mimic the lunar surface.
So my role in this project is to do the modeling and simulation, so create the simulation environment for the lunar dust. So the dust to dust or particle to particle, particle to surface interactions, we want to simulate those on the computers and then match what we know from the experiments, the physical properties, with what we get from the simulation. So we're trying essentially to close the loop between simulations and experiment to better understand the physical phenomena. So one of the major things we want to understand is the electrostatic phenomena that happen between particle to particle, particle to surface. We believe that this would be a major contributor to passive dust mitigation. So we want to understand via simulations and experiments and essentially closing that loop, how charge transfer, how lunar dust gets charged and discharged, and how the charge moves between the particles and the surface.
So there are a number of different approaches to thinking about ways we can clean things off, right? So we think about if we have sand on us at the beach, you can just wipe it off and everything's great. Sometimes you get a little scratched though when you do that, right? Just the grains are a little scratchy. That same thing can happen with lunar dust. It's even scratchier actually. So if you try to wipe things off of the surface, they're actually going to scratch your surface, maybe degrade the fabric, maybe degrade an optical surface so you can't see as well. So we need to find ways that can either change the surface itself or actively move dust off the surface. So part of our project will be done in an atomic force microscope system that is actually in a different lab. But in this lab, we have a couple of vacuum chambers. We have R2-D2 and warp core. And these vacuum chambers can get us into a decent vacuum, and we can put things like a UV light on surfaces, and we can do things to understand materials. And so in these vacuum chambers, we'll be doing some experiments with the centrifuge techniques, where we're spinning a centrifuge quickly and seeing how dust comes off. And we can also do some other characterization of the dust and its bulk behavior in the larger vacuum chambers.
We want to build a facility using this project that we can really take a look at the materials in space.